Today we shall do a demonstration of how to perform one-way ANOVA for repeated measures using Statistica. So in order to do that, let us present our problem. Dion, Burchard, and Walster examined the stereotypes we hold about attractive people. Subjects looked at 4 types of photographs of persons all unknown to them. One of a physically attractive person, one of a person with average attractiveness, one of an unattractive person, and one of a highly attractive person. Afterwards, subjects rated each photographed person according to how socially desirable the person is for him. Higher scores reflected greater social desirability. So let's now go to our data. So in this case, it is the research is sort of conceptualized in a way wherein we are saying that the level of attractiveness, which essentially is your independent variable, has something to do or has an impact on our perception of how socially desirable a certain person is. So in order to do that, there are 16 participants, and each of these 16 participants were exposed or were shown 4 different photos of people of varying levels of attractiveness, and they were asked to rate how much they think each photograph or each person in the photograph is socially desirable. So and with that, what we are trying to do is to try to compare whether the average perception of social desirability for those who are unattractive, those who are average in terms of attractiveness, those who are attractive, and those who are highly attractive, is there a significant difference in at least 2 means among those 4 means. So in order to do that, we have to perform one-way analysis of variance for repeated measures design. So just click on Statistics and then click on ANOVA, Repeated Measures, ANOVA, then click OK. Click on Variables and choose all of the levels of our independent variable, and then click OK, and then click this tab labeled Within Effects, and then it is asking for how many levels do we have in our IV. So there are 4 levels, and we can rename that factor as attractiveness. And then let's click OK again, and click OK again. Alright, so there are several options. Perhaps you'd like to look at the means first. Click on means and then observed unweighted, which will show you the means. These means represent the social desirability ratings for photographs of those people who are unattractive, average, attractive, and highly attractive. And we notice that in terms of the means, it seems that the more attractive the person gets, the higher the social desirability ratings are given. But what we'd like to know is whether these differences um, uh, are they significant, or are they merely happening by chance? So to do that, let's go back to our dialog box, then click on quick, and then click on all effects. Alright, so in here, particularly in this row, so this row, you can find whether or not the level of attractiveness has a significant impact on the social desirability ratings given to the photographs. And we can see that the probability is less than 0.05, which means that there is a significant difference in the means, at least in 2 of the means in our 4 different levels. So the mean square for error is the variance we expect by chance, and this mean square is the variance that is occurring in our specific data set. So we can see that the variance is much larger than what we would expect by chance. That's why our p-value, the probability that our results happen by chance, is very, very, very slim. So we now know that there is a significant difference among these. Now the next question, well, before that, perhaps you'd like to see in a more visual way. So let's return to our box. You can click on all effects, graphs, and then simply click OK, and it will show you the graph. So these represent the mean or the average ratings for social desirability for those who are unattractive, average attractiveness, attractive, and highly attractive. So we now know that somehow among these 4 means there is a significant difference. But the question is, which means are actually significantly different? Is it between the means of the unattractive and the average, average and attractive, attractive and highly attractive, unattractive, attractive, so forth and so on? So with that, we have to do a post hoc test. So let's return again to our box, and then click on more results, then click on post hoc. Then there are several options. Let's first check on significant differences. Click this one, and then you can click on Tukey HSD. So here you can see a matrix which compares the different means. So there are essentially 6 comparisons: 1, 2, 3, 4, 5, and 6. Now these comparisons, these values are a mirror image of the ones below, so you can just ignore them. So let's try to look. So these rows, by the way, represent the levels as well. So unattractive, average, attractive, and highly attractive. So if we compare the means of average and unattractive, so we can see that there is no significant difference in their means. There is, however, a significant difference, less than 0.05, between attractive and unattractive, and between highly attractive and unattractive. So at least 4 mean comparisons seem to show significant difference, while the 2 remaining comparisons, particularly the mean rating for social desirability between average attractiveness and unattractive, that's not significantly different, and the mean difference between highly attractive and attractive is also not significantly different, which if you look at our graph makes sense, no? So these two means are not significantly different, these two means are not significantly different, no? But these two are, and these two means are significantly different. Now the data also shows us that there seem to be two homogeneous groupings. So let's check on that. So let's click on homogeneous groups, and then let's click on cookies again, and there. So there are two homogeneous groups. So in terms of social desirability ratings, it seems that there is homogeneity in social desirability among the unattractive and the averagely attractive, and homogeneity in social desirability ratings for the attractive and highly attractive. Okay. So that's all that we can discuss so far for one-way analysis of variance in the context of repeated measures design.